In this video, we're going to take a look at a comparison between CNC and 3D printing. I want to get straight right away. This is not a critical comparison as to why one is better than the other. There's debates all over the internet for that, and frankly, I don't agree one is better than the other. I myself, my professional background is with CNC machine tools going all the way back to the 1970s. So I won't say I'm an expert on it, but I'm quite familiar with the technology, the history, the usability, application, and everything else related to CNC. 3D printing, I've been actively involved with it at the home level for the last, I'm going to say 3-4 years, maybe 5 years. So I've got a good experience with that, and I've also been around metal 3D printers in the industrial world. So my point of view is going to be obviously very much around the hobbyists' application of CNC and 3D printing, but I do have a very strong background in the industrial applications of both technologies. Now, for our comparison in this presentation, what I'm going to be looking at is just an overview of the workflow per se, or the process of going from design all the way through to running the actual part, or creating the part. The part that I've selected as an example piece is nothing more than, I think people on the internet and the maker groups call them a coin. It's just a 2.5-2.7 inch diameter medallion with my name engraved in it. One will be machined here on the CNC router, and one will be created on my 3D printer. Now, I'm not going to go into all the details of how to design and all that stuff. Again, this is an overview. But needless to say, we take it from that point all the way to completion, but not finishing. So here on the CNC machine, this would be what's called a subtractive process. You start out with a solid piece of material, and you're going to remove material from that to create the shape or form that you want. In 3D printing, it's almost the inverse process. You're taking a solid form, again, that starts out as filament, typically 1.75 millimeter diameter filament, which is the common diameter that we use in consumer or hobbyist 3D printers. We're going to take that, melt it, squish it down on a table, and then move the nozzle around to create the three-dimensional object that we're trying to create. So it's an additive process. So we've got subtractive on CNC, additive on 3D printing. The motion technology for both of them is very, very similar. We're going to move the tool at a programmed specific feed rate, or rate of feed. We're going to, in the case of the 3D printer, we're going to heat up the material in a hot end. On the CNC, we're going to spin the tool in a spindle. But again, the technologies are very, very much the same. In fact, if you look at the G code that runs a 3D printer, it directly parallels CNC machine tools. And of course, CNC machine tools have been around, I believe, since the 1950s in the form of NC, before there were computers. And then in the 60s, 70s, and so forth, moving forward to today, it's gone into computer numerical control, where computers are actually running the equipment. But again, for a comparison, the control technology, the motion control technology, is almost identical between the two machine tools or the two types of operations or machines. Virtually everything that you want to make, either on a 3D printer or on a CNC machine, needs to be designed. And that design has to be utilized in the creation of a program that will run the machine tool. As such, you have to follow certain rules to get to that point of a completed program that will run properly on the machine tool. Now, in 3D printing, because it is a newer technology, it is almost exclusively done in a 3D modeling application or program. That would be CAD, computer-aided design. And those can go from very expensive industrial CAD programs to many freeware ones that are available on the internet. They're all great. They can all solve certain problems for you. It's just spend what you can afford to spend, and you will have a tremendous amount of capability or just so-so capability. But nonetheless, you got to get through that design phase and get something that you can work from to create the program for the machine. In 3D printing, it's going to start as a solid or start as an idea. You will create a solid model, which is a graphic image within your computer system, and then that solid model is what you would use to create the program. It's almost impossible. It's possible, but extremely inefficient and difficult to create a program for a 3D printer in any other way than to start with a 3D model. On the other hand, with CNC machine tools, in the industrial world, they've been around since the 50s. Primarily, the industry grew in the 60s and 70s and really met its golden age of growth in the 80s and 90s. As a result of that, there are many, many, many machinists that were in the CNC trades, or still are, that know how to program manually. So they can look at a sketch on a napkin, a drawing in a notebook of something that needs to be made, and literally write the program manually. But that's, of course, dependent on the complexity of the part. The more complex the part, the more complex the geometry, the more the dependency on both CAD, computer-aided design, and CAM, computer-aided machining. Now, I don't want to go into the super heavy nuts and bolts of CAD and CAM and the advantages, disadvantages of different brands and so forth, but suffice it to say that a CNC machine, such as this router I've got here or my CNC lathe over there, can easily be programmed without the use of a computer or CAD or CAM software. Whereas 3D printing always starts with a 3D solid model, and then from there you're going to go into the processing program, which in the 3D printing world is called a slicer. And that just takes that solid model, slices it into a bunch of layers, all automatically, you don't have to do it, and then those layers are what the printer is going to use to draw that part with that melted plastic in 3 dimensions. On a CNC machine tool, for cutting operations, such as a router or a lathe, we need to use a variety of different tools. And we're going to apply those tools with very specific speeds and feeds to that operation so that we get an efficient cutting process and an accurate cutting process. And hopefully we're not breaking tools or destroying our workpiece to begin with. Workholding for 3D printers is pretty much straightforward. It's not without its problems, but most 3D printers either have a glass bed table. The table is called the bed, and your materials printed on that bed, and you need it to stick there until the printing process is completely done. If it comes loose at all, your 3D print is most probably destroyed. So your workholding is literally a flat plate. Now that plate today can be glass. Many people use mirrors, and then specialty flex plates that are two-piece devices where you'll have a magnetic sheet that is double sticky taped to your aluminum heat bed, and then you'll have a flexible sheet that is magnetically attached to that intermediate plate. And the advantage of that is, after it's done printing, you take the flex sheet off and you flex it and your part pops off. The biggest problem on 3D printing or with 3D printing is getting adhesion between what you're printing in that bed. And there are some common practices that add a great amount of reliability to that process. It is not foolproof by any stretch of the imagination. People have problems with some of the best add-on type print beds. And yet some people can just simply put masking tape over their print bed and print every day, year-round, have no trouble with any filament. It's problematic, but with work and effort, you can get it to run pretty reliably. For a CNC router, you're going to have to look at a variety of work holding options. On this one, I've got a very simple sacrificial board over in this area that is used for milling my circuit boards. I machine it flat almost before every use because I need that engraving to be very, very precise in depth. And I use double sticky tape to hold my circuit board material to that sacrificial board. On this particular area is another sacrificial board, and I use this one more for routing bigger objects, probably wood or plastics. Again, I use double sticky tape there. Back in this area of my CNC router, I've got a vacuum chuck. And the way that works, there's a vacuum line, a vacuum source that is plumbed into this area. I put, we'll call it a tubing, surgical tubing in here to seal off the area where I'm going to put my workpiece. I'll suck out the vacuum or suck out the air in between that tubing, which would roughly go right around the perimeter of the size of part I'm putting on here. And that'll hold it very securely for the routing process. Moving on from there, it's extremely varied the type of work holding you will use. You could use metalworking vices, such as this speed vise that I picked up used from a coworker a few months back, or other types of precision metalworking vices, or even simple plastic vices that you've 3D printed. Sometimes that's all you need. Other times you may be clamping your workpiece or fixture or something directly to the table using a variety of tool clamps. But the important part here is the amount of different types of work holding used in CNC. And that truly translates over into CNC turning as well. You don't just use one type of work holding even on a lathe. Now moving on from work holding, let's go into the next component of everything, and that's tooling. With 3D printers, you really don't have a lot of tooling to deal with. You've got a nozzle. That is your tooling. Your material is fed to that nozzle, heated up in the nozzle, and it squirts it out. So you really select between the available sizes of nozzles for your printer. And I would say, just as a rough rule of thumb, you're looking at about a 0.12 millimeter at the small end diameter nozzle up to, we might even go as high as saying a 1 millimeter diameter orifice on a large nozzle. So that's your choice, and you're going to select one choice, and that one choice will be used through the entire printing process for that particular project. On a CNC router, you're going to be selecting between a very wide variety of tooling depending on the complexity of your part. On this particular router, I can hold up to 1/2 inch shank or roughly 13 millimeter shank tooling. The spindle is 22,000 RPM, and it has about, I think, 2 horsepower. So it's pretty good spindle. Now, the bearings are shot on it, but it's a pretty good spindle. Now, as you can see, you've got different size collets here to hold the different size tooling. And then you've got all the different types of tool, most of which I use is in the 1/8 shank variety for circuit board milling, but I've got a very large selection of woodworking router bits that I use as well. Now, the thing with the CNC router, all those tools have to be measured. So unlike the 3D printer, where you pretty much just put the nozzle in and maybe have to recalibrate its location to the table, that is good for that entire use of that nozzle. And that'll work on every program, and you don't have to reset that all the time. On the CNC machine, all your different tools, especially without an automatic tool changer, you've got to measure each tool to the part every single time you use it or change it. So if I take this tool out, put it back in, I have to remeasure it. Now, that process can be very simple per se without needing any technology, and that is you just jog the tool down on top of your part and then enter a number as to where that part in the tool touch. And that would be into an offset. With this particular machine, I've outfitted it with a very crude probe. And I just bring the tool down, or I literally run a program that brings the tool down to touch the probe. It automatically records that offset value and then goes back home again, very simply. But nonetheless, think about a program that's got 10 tools, and each tool is used for, say, 1 minute of cutting. After 1 minute, I've got to be here to measure the next tool when I reload it, over and over again all the way through that program. If I'm making multiple parts, I'm doing this multiple times. So it can be a laborious process, and it requires you to be here and attending to the machine. Now, the other thing that we have to be concerned with is informing the machine tool, the 3D printer or the CNC router, where the workpiece is in relationship to the tool. Now, we just talked about measuring the tool length, and that's kind of a combination of telling the machine where the part is along z-axes, as well as informing it the length of the tool. Now, for X and Y, on a 3D printer, when you import your 3D model into your slicer software, you will place it on your table. It's, of course, in the virtual world. That is your program 0. That's all you need to do. You don't need to measure anything at the machine to set that 0 location. On a CNC router, I would literally have to jog the tool or some device, an edge finder, a wiggler, an indicator, something, jog that over to my workpiece, and depending on the precision required, very carefully touch that workpiece, record the values, and then enter those into an offset value. Now, for simple projects like this coin that we're making in this demonstration, that process doesn't have to be perfect. It could be within a 1/16 of an inch, and I'm okay. So doing it on this particular project, touching off the part 0 location, literally takes less than a minute, probably 30 seconds if I'm moving slow that day or something. So it's quite a simple process on a crude part. The more precise you need to be, the more careful you have to be, and that process can be maybe a couple of minutes in duration. But nonetheless, that is something that's very different between CNC and 3D printing. And continuing on with this idea of getting from program to running a part, the process is overall called the setup process. And that's where you're going to set up the machine. On the 3D printer, if you had to change your nozzle size, now is when you would change that nozzle to a different diameter nozzle, and then you would probably have to calibrate that to the top surface of your bed. If you're changing material, your plastic filament, you would change out your filament by removing the old filament, putting on the spool of the new one, run that through, and get it feeding into the nozzle. And loading your program. That's your setup process for a 3D printer. Even with a filament change, a different program, and a nozzle change, that whole process could be done in about 15 minutes, probably less. And most of that time is, if you're changing the nozzle, you need to do that when the nozzle is up to temperature. So of that 15 minutes, most of the time is in just letting it warm up, and then from there doing your calibration. Very, very simplistic on a 3D printer. CNC router, now as I just went over, you've got to measure all your tools. Now if you've got a tool changing CNC router, you could measure those tools in advance, because as they change on an automatic system, their length is consistent. The tool would always go into the spindle with the same projection amount. So you would have to measure them at that time or during the program run with a manual tool change spindle. Touching off the location would be part of your setup process. So we just described that. And then your work holding. You would have to develop a fixture, pick the right vise, a spoil board, maybe qualify it. So your setup on a CNC machine can certainly be much more elaborate and involved than on a 3D printer. Now in truth, when I'm doing circuit boards or simple engraving here or here, that process isn't very long for the way I've got my machine set up. I keep these fixtures on the table until they're no good anymore, and then I put a new one on and requalify it. So realistically, it's a lot of steps to do all of the work holding, the tool measuring, the part measuring, getting everything ready. It's a lot of steps, but it's really not that difficult or time consuming. Now for this coin project, I'll be going into some comparisons of how much time along the process it took for cutting, setup, and so forth. So that might give you a little more insight into a difference between 3D printing and CNC machining. Now during the run process on 3D printing, there's one general rule that most people tell you to do. Once you start the process of 3D printing, you should watch your first layer, at least till it gets a little bit of a start, and then check after that first layer, or at worst the second or third layer. You want to make sure that you've got good bed adhesion. And then from there, you're probably in good shape for the rest of the print to finish up. Now there's things that can go wrong. You can get a clogged nozzle because there's an impurity in the filament itself. Remember, these are very tiny holes on that nozzle. Say you're at a typical nozzle of 0.2 millimeter. That works out to 0.008 of an inch, or less than 3 thicknesses of a piece of paper. Very, very small, so anything can clog it up. Well, if that nozzle gets clogged, nothing comes out. You're 3D printing air, so nothing really happens. But for the most part, 3D printers can run very unattended. You don't have to watch over them. Now, when machining on a CNC router, because there's much higher horsepower, much sharper tools spinning at very high speeds, you should be keeping a close eye on the process and not just letting it run completely blind. That is done very, very frequently in the industrial world. Many, many CNC machine tools in the industrial world are loaded and unloaded by robotics, and they run without any human intervention at all. Of course, the big difference between the industrial world and the hobbyist world is, in the industrial world, there is a tremendous amount of logic put into the controlling program of the CNC machine and robot. There are many, many, many safety features built into that combined process between robot and CNC machine tool. And the processes of the actual metal cutting or whatever you're machining has been proven out for a very long period of time with great engineering study done to ensure that these will run reliably and safely. We're not afforded that in the home shop. So that's where the burden of responsibility is back on your shoulders to pay attention to what your machine is doing so that it doesn't self-destruct, crash, collide, tools break, things fly around, and so forth. So that to me is a big difference between CNC machining in the hobby shop versus 3D printing. I'm more comfortable letting the printer go for a couple hours without looking at it, but I wouldn't do that with my CNC router, even though I've been running CNC routers in my home shop for the better part of 15 years. Now we'll take a quick look at the actual process. I've got a time-lapse film of the 3D printer operation, but it goes by very, very quickly. So I'll probably replay it a couple times so that you can kind of see what the process looks like. But the total cycle time for this particular part was 1 hour and 20 minutes. I was printing at a 0.16 millimeter layer height at 60 millimeters per second. The material is PLA. which is a very common plastic used in 3D printing. The setup and manual intervention was less than 10 minutes during the entire process. And the programming time to convert from that 3D solid model to a usable program to run the 3D printer was far less than 10 minutes. But sometimes I need to account for a little extra time, getting the program communicated over in the different ways that I do, getting the time-lapse camera set up and so forth. So the process of programming the machine for 3D printing can be a very, very fast process. It can easily be done in many cases in less than a minute or two. Now moving over to the CNC router to make a comparable similar part. On the CNC machine, it ran at 8 minutes and 38 seconds of total time, including tool changes. By comparison, if you don't remember, the 3D printer cycle time was 1 hour and 20 minutes. So from 1 hour and 20 minutes comparing to 8 minutes, 38 seconds. The tools, there were two different tools used. One was an 1/8 inch flat bottom end mill. The other was a 1/16 inch ball end mill, and that was used for the engraving of the letters. The spindle was programmed at 15,000 RPM, and the cutting feed rate was 25 inches a minute. The material in this case was mahogany. Setup and manual intervention was less than 20 minutes, probably closer into that 10-minute range, but I'm trying to give a more realistic number with the 20 minutes. Programming time was 25 minutes. Now in truth, the reason why it took 25 minutes for me, I used Fusion 360, and I don't use that program very often, the CAM portion of it. And they had changed a good number of things in the software since the last time I used the machining portion. In fact, it's been probably over a year since the last time I used that software to develop a CNC program. So in that year and with all the changes, I had a lot of relearning to do very quickly to get the program. I'm comfortable now with the changes they made to the software, so if I sat down today to write that same program from the 3D model, it'd probably take me in the neighborhood of 10 minutes or less without a whole lot of worry or concern. Here are the two medallions side by side, and they both serve a purpose. They're both usable. My personal preference would be the mahogany one over the plastic one, but that's really truly dependent on the ultimate purpose. Now the next step after this would be finishing. Off the 3D printer, you can use a lot of projects straight off the printer without having to go through and do any additional finishing. Same is true for the CNC router. Depending on the part and the application, the material, you may or may not need additional finishing. But that is a big story for another video entirely. So hopefully this video gives you a good overview of the comparable processes between 3D printing and CNC routing as it exists in the hobbyist shops. Now, if you have a desire to learn more about applications and use and programming and all these different things of either 3D printing or of CNC machines, either turning or milling, let me know in the comments below. I've got a lot of extensive experience with CNC especially, and I'd love to share some of what I know with everyone. But the only way I can determine that is if you give me some feedback in the comments, perhaps give me some thumbs up on this video, and if you haven't done so already, please subscribe. That's really the key to helping me grow this website or YouTube channel. Thanks for watching, and I look forward to seeing you in the next video.